Exploiting SQL injection in Java. The Java Database Connectivity API, also known as the JDBC API or simply JDBC, is a specification defining how Java applications should interact with a database. The specification exposes two specific classes that, when used incorrectly, will result in SQL injection: the statement class and the connection class. Let's review how the JDBC API can be used to implement a common piece of application functionality. This code snippet emulates how authentication is commonly performed in connection with a back-end database. The first two lines of code obtain the username and password from the HTTP request. Lines 4 and 5 connect to the database and create an instance of the statement object. Lines 7 through 9 are responsible for executing a SQL query to verify that there is indeed a row in the database whose user and pass columns match the user and pass parameters retrieved from the HTTP request. This code snippet is vulnerable to SQL injection because it dynamically constructs and evaluates a SQL query in conjunction with attacker-controlled data. How would an attacker go about exploiting this vulnerability? Let's review by what means an attacker would attempt to log into this application through the browser. Consider the case when the attacker provides a user value of admin and the following value for the pass parameter. The Java application will take these inputs and produce the following SQL query. The hacker has modified the SQL query to completely negate the value of the password check in the SQL query. This query effectively looks up any row in the user's table where the username is equal to admin. And that's it. As long as there's a user in the database with the name of admin, the attacker will be able to log into the application without a valid password. Misuse of the connection class to create prepared statement and callable classes can also result in a SQL injection vulnerability. Consider the following Java code snippet. This code snippet illustrates how the same query can be executed via a prepared statement or a callable statement, but does so insecurely. The prepare statement and prepare call methods of the connection class accept arbitrary SQL code that is then pre-compiled in memory. If the application makes use of attacker-controlled data when constructing the first argument to these methods, as is the case in this example, then the app is vulnerable to SQL injection. Technologies such as Hibernate and iBatis will wrap JDBC and expose a facade that emphasizes the utilization of high-level objects rather than raw SQL code. However, ORM technologies will still expose API that are vulnerable to SQL injection in ways similar to the direct use of the JDBC statement class. Consider the following two code snippets. These ORM technologies provide different ways to express dynamic SQL queries. However, in both cases, the code dynamically constructs and evaluates the SQL code in conjunction with attacker-controlled data, and thus is vulnerable to SQL injection. If used incorrectly, ORM technologies such as Hibernate and iBatis can still result in the introduction of SQL injection vulnerabilities and result in a massive data breach.